Welcome to the Beyond the Reef podcast, where I talk to experts and researchers in the reef aquarium hobby, discussing a broad range of topics from corals and reef biology to water chemistry and equipment. We take a deep dive into our guests' methods, techniques, and top reef keeping tips. My name is Adam Sutherland, and I am the owner-operator of Frag Garage Corals, based out of British Columbia, Canada. This podcast is now brought to you by Fauna Marine. I was hesitant to bring on any sponsors, but since I use so many Fauna Marine products, I was really happy to have them collaborate with me. And also, I am now a certified ICP consultant, so if you send in a laboratory ICP test, you can select me as an advisor. What's up, everyone? This is going to be a little bit of a different style of episode today, and I apologize for the delay in delivering this one. I wanted to talk to a couple different people about dissolved organic carbon, which has been a big discussion thing recently, mostly thanks to this article by Salem Clemens, who you know from Reef Builders. So first I talked to Christoph from Oceamo because they have added the SAC 254 to the Oceamo laboratory test, so you get a little bit of an indication on your carbon levels from that test. This is also being added to the Fauna Marine test, which will be just a small little fee as a paid add-on to the total ICP. So since we had this discussion, this has been a new thing that's been added. And then, of course, next I talked to Salem, who's really digging deep into this stuff. I mean, I feel like it's still... These are things to start thinking about, but it's such a gigantically broad area that we're only scratching the surface of it. But I do think that it potentially is going to help us start to think about our tanks in some different ways and potentially, be a source of problem solving for ongoing issues. And these DOCs clearly have a relationship with bacteria in our systems too. So we got a lot to think about, I think, in the next few years coming up as far as this stuff. So I hope you guys enjoy this conversation. I hope it is insightful and thought-provoking, and I hope to hear from you. Now for a little housekeeping stuff, I'll be quick. Just in case anybody has submitted an ICP and selected me as an advisor for the Fauna Marine ICP, probably the best way if you're international and not in Canada is to subscribe to the Patreon. Now you can just do one session with me and cancel the membership, or you can just continue and we can have a meetup once a month. We don't just have to talk about your ICP. We can talk about really whatever you want in terms of your tank. I give life advice too, whatever you want to talk about. And yeah, so as per usual, please hit subscribe. Sharing episodes is really helpful. Like, comment, let us know what you think. Get some conversations going in the chat. That's always super cool to see. And I hope you enjoy this one. Yeah, I thought we could talk about this DOC stuff. DOC being, dissolved organic carbon? Is that generally the...
DOC is dissolved organic carbon, and we don't measure DOC directly. We measure another parameter. It's called SAC 254.
Yeah. Okay. So tell me what that is exactly.
That's difficult to pronounce. It's the spectral absorption coefficient at 254 nanometers. And how this is measured, it's we use your water and shine like light of a specific wavelength through it. In this case, 254 nanometers, which is like in the UVC region of the light spectrum. And different types of organic molecules that are like dissolved in the water absorb this type of radiation. So like the intensity of light that comes out of the sample is lower than the amount of light that is shined into the sample. Yeah. So we get some absorption, and like the absorption is more, the more organic compounds are in the water. So this is not a very specific value. This is like a sum parameter, but it's a fairly good indicator of the concentration of dissolved organic carbon. Yeah.
Okay. Cool. Yeah. So I think was this something you were thinking about doing for a while? Because a lot of us read Salem's really great article and some of the research he did. Was it kind of inspired from that, or is it something you wanted to add to the test for a while?
I've been thinking a bit for a long time. I mean, there's other companies that are measuring DOC for quite some while now. I must say I was always a bit skeptical because I was thinking there's quite some variation, in dependent on the last feeding and depending on different times of sampling and so on and so
Hmm.
forth. And so we
Yeah.
started testing. I think this was like half a year ago. So I guess before Salem came up with the issue
Okay.
to investigate, our own tanks and some tanks that are close to us. And we
Hmm.
also did some sample stability studies that we, took the water and just stored it at ambient temperature just in the tubes, and we measured it every week to see, how stable this is over
Yeah.
time. If there is some, when you ship the sample, if you have some completely different values. And it was quite interesting that the tanks with, constant husbandry conditions had very constant values, maybe like a few percent lower
Hmm.
this week or a few percent higher, but generally they've been very, very level. Yeah. And also
Hmm.
with the stability of the measurement, we didn't see any decline over like 4 weeks. So this is why it really qualified as as a parameter to add to the
Yeah.
analysis. And I've seen that there was quite a demand for it. Yeah. So I
Yeah.
mean,
Well,
we
the
already
timing was really good for Salem's article to come out because, I think that discussion needed to be started because, the point he kind of makes is that, we have a pretty good grasp on our inorganic chemistry in our reef tanks. Like we have a lot of good data from, tests
exactly.
like
Yeah.
what you do, but, there's always this other factor that, clearly has an effect on our tanks. I mean, I guess the other equation is bacteria and things like that, but,
Sure, which
you
which
know,
is influenced by organics, of course. I mean,
yeah.
we still have a much better look onto the inorganic side because we know all those individual elements. With the organics, we're still at the phase where we have like, a sum parameter. We can say, okay, there is a lot of organic or there's not so much organic, yeah. But we have a hard time differentiating like, okay, what type of amino acid or whatever is there. Yeah, so there is still something to learn, I guess. Yeah, but
Yeah.
uh, I'd say it's still a very good starting point to have like this overview. Okay, is my tank high on organics or is it low? And what is the effects and which
Mhm.
husbandry techniques or changes can I make to influence this value? Yeah, so I'm really happy that Salem brought it up, and
Yeah.
it's for sure a very important point. Yeah.
Yeah, yeah. So I guess speaking about some of that stuff, what would you say are some of the most major inputs? Is it kind of just like everything you're putting into the tank that's things like feeding, and really it's like water clarity is kind of your biggest way to sort of see it, right? Like
Yeah, you can't
in
you can't
general.
I mean, there is some organics, obviously, that are colored, like some
Mhm.
polyphenols and stuff like that, which give like, this brown or yellowish coloration of tank water. You see it when you do a water change, and the bucket,
Yeah.
you have it in the white bottom bucket, and you really
Yes.
see, there's some yellowish color. But that's not always the case. I mean, many of those organics are colorless, so you don't really see them. Yeah.
Okay, but these are still organics that are picked up by the SAC
Exactly,
254.
exactly.
Okay.
We don't need any coloration in the water to pick it up. Yeah.
Okay.
Um, it's the sources of feeding, but the sources, of course, also like, substances that come from metabolism of different organisms. Might it be
Mhm.
corals or bacteria or yeah, microbiotic life, yeah, which is
Mhm.
like, the mucus of corals. It's also shed into the water column and
Mhm.
is adding a lot of organics to the water. It's different kinds of peptides and proteins. There is quite some free amino acids in the water that are contributing to this sum parameter. And I guess there is many more compounds we don't know about yet. So it's
Mhm.
a very interesting field.
So would you say potentially a more heavily stocked system might typically have a higher like rating on this scale
Um,
because there's more biology kind of per
that's
gallon happening?
could very easily be, yeah, but it's always that's the input part, and you have the output part as well,
Yeah.
like the
Yeah, yeah.
skimming and the carbon use. And
Mhm.
I'd say that when the output isn't working as it should, if your skimmer is undersized or doesn't work, or your display some water turnover number is very low, and we had quite some cases of this, yeah,
Mhm.
then you just have an accumulating effect.
Yeah. Yeah.
And even at lower stocking levels. So it would be too easy to say that a high stocking level leads to a high SAC value. You
Mhm.
always have to look at the import and the export at the same time.
Yeah. Yeah.
Mm.
So we kind of looked at the inputs. So as far as the exports, I mean, I kind of have a list here, but you mentioned protein skimming, activated carbon, obviously, but then we
Yeah,
need to talk about the trade-offs of the activated carbon because
sure.
what inorganic trace elements is activated carbon potentially messing with a little bit.
I mean, we've got an article on our webpage where we really investigated all the trace
Okay.
elements and the effects on different adsorbent materials on it. Um, Carbon is not as bad as like phosphate adsorbers, especially
Yeah.
GFO types, but
Yeah,
by
we know
far
GFO is bad news for
is
ICPs.
bad
Yeah.
news for trace elements. Yeah,
Yeah.
but carbon still binds copper, for example, and
Mhm.
also depends how much those trace elements are bound to organics, because copper is one of the elements that has really usually very strong binding to proteins and to other organic substances. And so it's not the copper by itself that binds to the carbon, but it's the protein which has the copper sticking to it, and this is
Mhm.
afterwards removed. Yeah,
Interesting.
yeah.
Okay.
So
Okay.
it's fairly complicated. So some things we need to investigate is when you have the higher SAC, the higher organic levels, there is also a better chance to have like all the trace elements in like a chelated or bound form, and thus it might be easier to export them, so that it might be easier to run into trace element issues. Yeah,
Okay. I see.
in
Yeah.
comparison to very low organic tanks, which
Mhm.
might have like a higher portion of non-bound trace elements. But
Okay.
this is a field that's really unexplored. So there is a lot
Yeah.
to do and a lot to learn.
Yeah, that sounds like an interesting direction to go in for sure. And will this be something you guys will be looking into and testing more?
Sure, sure,
Yeah,
yeah.
yeah,
But
yeah.
there
Because
is
figuring out, how things are bound and removed and, these inputs and outputs, it's like there's so many variables, and the more you can start to narrow that down, I think is, going to be really
sure. I
helpful.
mean, everything every new data puzzle piece you gather is helping in the end effect to understand your tank and to make
Mm,
husbandry easier. And it was also with the GFO effects. I mean, we didn't know this before, how drastic those effects were. And so now when somebody's using GFO, we are dosing like extra cobalt and extra selenium and extra vanadium, because those are the elements that are really, bound the most.
mhm,
And yeah, way easier if you know about it. So knowledge
mhm.
is really power here. Yeah.
Yeah, I just anytime somebody tells me they're using GFO, I tell them to get it the fuck out of their tank.
I mean,
That's
it's
what
really,
GFO stands for.
I mean, it's yeah, I have to remember this one. No, it's very usable and for phosphate remover, of course, and it's very
Yeah,
effective. But you always
especially in
have
a
to,
fish only or something like that, right?
yeah, you
Yeah,
always have
makes
to.
sense to me.
There's always two parts of the medal, and the same with lanthanum. I mean, it's effective in phosphate remover, but you might have run into issues with your fish. Yeah.
Yeah, totally, totally.
So there is
Yeah,
there is no solution. At least I'm not aware of any phosphate remover solution that hasn't have a downside as well.
yeah.
Mm.
Totally. Yeah. Okay, let's talk about these exports a little bit more. So skimming, mentioned nothing really specific to say about skimming. I mean, probably if you're skimming wetter, you're going to be pulling out
Yeah,
more
exactly. And
quickly. So,
and but
uh,
I don't know if it's common on your part of the Atlantic, but in Europe, it's you quite hear often that your return pump. There is no need. It must be like have any more water flowing through it compared to the skimmer pump. Yeah,
mhm.
which is in my case not really the case because the skimmer releases like this already skimmed water back into the
Yeah,
sump, and there
yeah,
might be some back mixing. So the skimmer might, again introduce water that has already been skimmed like a
yeah,
short time
exactly.
ago.
Yeah.
So you always want the highest gradient. So you
Mhm.
always want to supply your skimmer with fresh water from your
Yeah.
tank.
So
So
faster turnover. Yeah.
faster turn.
Yeah.
I mean, not nothing like 10 times per hour, but
Mhm.
at least 3 or 4 times an hour would be
Yeah.
beneficial. Yeah,
I agree totally. Yeah, and then another obvious one, I mean, probably the most obvious way of getting these compounds out is water changes,
sure, sure.
but
But it's gonna be an
yeah.
interesting part how, the freshly made salt water is behaving in this test because we didn't do a lot of testing in this regard yet.
Mm-hmm.
And also for the, for this is just something nobody has looked at
Hmm.
before, really, also for new salt water.
So
So
have
it
you
might
tested new saltwater with the
not not
SAC
not not
test?
not yet, but
Yeah.
yeah, this is gonna happen, yeah.
Hmm.
But uh,
Interesting.
it's also my feeling that fresh salt water usually will have a very low SAC value. Yeah.
Hmm. Yeah.
And if that's the case, then of course water changes will help. Yeah.
Yeah, yeah. Okay. The next thing I had written was ozone.
Hmm.
What are your feelings on ozone? Because I've been kind of thinking about giving it a try. I also forgot to mention at the start of this discussion that I did get a fairly high reading on the SAC
Okay.
score. I got a 12, which your range is, what is it, 4 to 8? Something like
It's
that?
I think it's 2 to 8 we have at the
2 to 8.
moment, but this
Yeah.
is not carved in stone, so there might be some changes. But 12 is pretty high, so most
Yeah.
tanks are well below this value. With ozone, ozone is fairly selective, yeah, and
Mhm.
ozone is like breaking down unsaturated systems, like especially those phenols we've been talking about that give the yellow coloration in water.
Mhm.
Ozone is really effective reacting with those, breaking them down. They are losing the yellow coloration. They get into a more skimmable form. So
Mhm.
ozone is of course effective in lowering this value. Yeah.
Mhm.
Um, you need to be careful because ozone, because it's such a strong oxidizer, we also oxidize your ammonium and we also oxidize our trace elements. So when
Mhm.
you're dosing your trace elements, usually you have some time points a day where you're dosing the traces. I'd
Yeah.
recommend leaving some gap in between ozonization and the trace element dosing to
Okay.
have the
Yeah. So maybe at
ozonization.
night versus
y-
if you're dosing more of
Yeah,
your
or
stuff during the day.
it
Yeah.
can be sufficient to have the ozone running like for, 2 times 2 hours per
Mhm.
day or 2 times 3 hours, something like this. Yeah. And then just have your trace element dosing separated from those ozonization timeframes.
Okay. Yeah. So it sounds like the ozone is a little more uh specific on which type of carbon it
It,
will target.
it is because you need some sort of unsaturation. This is like, carbon-carbon double bonds or triple bonds or aromatic systems. Those are really prone for ozone attack.
Hmm.
And
Hmm.
like the ozone breaks those bonds and more or less attaches like more hydrophilic
Hmm.
functionalities there, like alcohols or carbonic acids, and those get skimmed out quite efficiently. So it's fairly selective, and it really improves like the skimmer efficiency.
Yeah, because I guess what it is, I mean, this is my really layman understanding of it, is the ozone is O1, which is a really like active molecule, and then
It
some
is.
molecules want to attach to that, and
Yeah, yeah,
depending on which
it's
ones,
like
yeah,
small Pac-Mans that
yeah,
are
yeah, yeah.
hunting like
Yeah, totally, totally.
yeah.
Yeah, okay. I mean, I might give it a try, and as I did have a high level, and I've been increasing water changes a little, but I'll see if I can get the level down because, like you say, 12. I mean, I don't know what scary level is, but do you think I'm kind of riding the line
I
a little
mean,
bit?
there is no scary level where it's not like copper where
Hmm.
you have like a certain concentration and can expect that the die off of corals, for example.
Yeah.
What we've seen so far from our data is that most, not all, but most of the tanks that have like a high SAC value suffer from cyano.
Hmm.
And many also suffer from dinoflagellate issues. I mean, we ask about those things when people are submitting their sample. So we
Hmm.
have this correlation of issues people are reporting versus water parameters we are gathering through the analysis. So and I mean cyano they are very efficient in absorbing whatever there is in the water column for their own
Yeah.
purpose. Yeah. So if you have a higher level of organics, I mean that's a no-brainer, so to speak, that cyano can benefit from it. But it's
Yeah.
not a must. So there can be high organics and you still having no patches of cyano, but the risk is
Yeah.
elevated for sure. Yeah.
Well, that's my case. I mean, I don't have any problems with cyano or,
Yeah.
dinoflagellates, but
Good
I
for you.
feel like the higher dock level is maybe making some corals more prone to having certain kinds of issues with bacterial infections and things like that. Is that suspicion kind of make any sense? Like,
Uh, uh, for my liking, it's too early to really draw this
mhm,
conclusion. I mean, it would also make sense, yeah, but it's
mhm,
it's nothing. It's often that things seem obvious, but then turn out not to be the case after all. Yeah. So for me, it's a bit early, but might be the case. Yeah.
yeah, yeah, because my thinking is that some of these strains of bacteria might be more partial to certain organic compounds, and if there's more of a certain type of, say, amino that, or I can't speak to the chemistry side, but if there's something that's more prone to
Yeah.
feeding certain strains versus others, then they could proliferate and become more of a problem
Could
in a
could
system.
could easily be, or that corals are just weakened by the presence, because the mucus layer of a coral, I mean it's loaded with organics, it's
Mhm.
uh, different carbohydrates basically, so different long chain sugar molecules which are usually food for bacteria. Yeah,
Yeah.
but at the same time, the corals also excrete like substances to more or less control pathogens,
Mhm.
and if there is stress factors like this ability to regulate those pathogens in the mucus layer might just suffer, and
Yeah.
this is where the high SEC value might be a contributor, as well as might be elevated trace elements and elevated temperature and other stress factors. Yeah.
Yeah, yeah. Other so many factors to that side of things. But
Mm,
yeah, in my case, I think this is something I'm just trying to improve and to see if that makes my system better. If I
yeah,
get
sure.
that number down, I can, share that observation and say, hey, I got it down from 12 to, 6 over the course of a couple months, and the tank looks way better. I haven't seen anything die or recede, or even hopefully some of the corals that had some lack of polyp extension or something turn around, something
Yeah,
like that. It'd be nice to have
please
some data like that.
let me know your observations.
Hmm.
Yeah.
Yeah, definitely. Okay. I guess another thing on the list would be like mechanical forms of filtration, like a filter roller would probably be good at pulling some of those compounds
Um,
out as well, I would
I mean,
imagine.
it would never pull out the compounds themselves because
Hmm.
they're like really dissolved. It's like
Okay.
if
That's
you
why they are dissolved organic
that's why,
carbons.
yeah,
Yeah, yeah.
it's just anything particulate, which is like
Hmm.
nothing that's dissolved. It's just just stuff floating around basically.
Yeah.
You can get it out, and it doesn't have the chance to decompose further
Hmm. Hmm.
to release really dissolved stuff into the water.
Yeah. So if you are doing, if you're doing filter roller, you're probably nipping it at the bud a little bit before it can dissolve and become part of the
Yeah,
water
I
column,
mean,
to an extent, maybe.
I can't really, there's a big maybe because I can't really tell you if it's we didn't have those control experiments
Hmm.
of tanks with filter roller versus non-filter roller, and there is so many other factors, so you can never break it down to this one device. Yeah,
Yeah.
but it sounds reasonable that it has some effects. Yeah.
Yeah, because I would imagine a system doing a filter roller versus filter socks that are only changed once a week or so is going to be a little bit of a better situation. But I think, maybe
I
we'll
mean,
learn more.
the skimmer, in contrast to the filter roller, really takes out dissolved stuff. Yeah, the skimmer has the
Hmm.
ability to really, bring on this layer, on this interface between air and water, a lot of dissolved molecules just accumulate and get skimmed out. And I've heard it quite often. I don't have so many, first-hand experiences because I don't use a roller, that skimming is not as effective when you use the filter roller because much of the smaller particulates are already, taken out. So the skimmer has less to do, so to speak, which, you can see with less skimmate formation and so on, and less stable skimmate form that's building up inside. And this might have like even, the effect that the SEC causing organics, dissolved organics, might not be so easily skimmed out because the
Hmm.
skimmer is not working as effectively. So
Hmm.
for me, it's not really sure if the mechanical filtration is helping or not helping so much in this case.
Yeah, or even, say like detritus removal, like may not necessarily have a huge effect on that. Because I've seen amazing systems that have tons of detritus in the sumps, and then
Yeah,
I've seen
yeah,
some
yeah.
people that are just completely meticulous about siphoning it, and
Mm.
I'm still not really settled either way on how important that is.
I mean, detritus is mainly there is a lot of inorganic precipitation in there. That's a lot of
Mhm.
calcium carbonate and yeah, stuff like that, and
Yeah,
strontium, and of course also some traces. Yeah. Um, to me, it's not really an issue to have dendritis. Yeah, when it's not like a huge amount.
yeah. Okay, that's good to know. One thing I guess in terms of this is what's the relation of I've actually never have run ORP probes. Like I've always gotten the basic Apex, you know, unit that doesn't have the ORP because it's just not
Yeah,
a parameter I was concerned
yeah,
about.
yeah.
But is this some indication, into the relation of these
In
values?
in my opinion, not because the ORP just tells you if there is more oxidizing or more reducing compounds present,
Mhm.
and with the organics, it's not really sure what side they belong to. Yeah, so I can't really say that the redox value is really a good indicator here.
Mm. Yeah. Yeah. I
It's
mean, I
also,
wonder if someone, for me having a higher level and then getting it down, I wonder if that level would rise up on the ORP. But, I don't know. There's,
I
like you
mean,
say, there's
with
a lot of factors.
ORP is very good to control your ozonization
Mhm.
because you can really see if you're overdoing it. Yeah, when ORP is
Okay.
getting too high. Yeah. Um, But yeah, I mean, we also don't measure the redox potential here in the lab, so I can't really correlate it.
Yeah.
But very difficult to tell.
Yeah. But probably a good idea if someone's running ozone to combat some of these things to have
Yeah,
ORP.
sure. I mean,
Yeah.
with
Yeah.
ozonization, less is more often. So
Yeah.
I'd really recommend, running at a low level and not running 24/7, but only like those few hours a day. And then usually, if you use your skimmer as a reactor, and you don't smell ozone, and ozone, the nose is a very effective ozone detector. If you don't smell it, you're usually fine.
Yeah. Okay. That's a
So
funny way
so
to test it, the non-scientific way.
yeah, I mean
Yeah.
the nose was always very important to the chemist. Yeah.
Yeah, that's true. That's true. That's fair. All right, thanks for listening so far. Moving on to my second guest, Salem Clemens from Reef Builders, who wrote this amazing article. Really got a lot of us thinking. Make sure you check it out. It will be linked in the description. So check it out if you want to get into some serious depth on this stuff. And I hope you enjoy the second half of this chat. All right, man. Cool. Well, thanks for making some time. I just want to say, first of all, like, thanks for writing this article. I think it's got a lot of people thinking. It's, a good stepping stone for thinking about an aspect of the hobby that I think has kind of been overlooked and maybe part of the equation that, I don't know, I was thinking about tanks having kind of hitting a stride. Tank does well for a while. You might be able to explain some of that from your inorganic chemistry, but then sometimes you just really don't know what that other equation is. So I think this kind of puts it into, potential perspective.
Yeah, this is the beginning of the end, I think.
Yeah.
But there's a lot more. Like, say, I've got all my research that I've not talked about really at all. This is kind of the first piece of this puzzle that I am publicly releasing, but there's a lot more that will be coming out probably in the next couple months. By March, it'll hopefully all be public. So yeah, this is organic chemistry is big.
Yeah, for sure. Because one of the things I have looked at in the history of my tank and since doing, laboratory ICP testing is, sometimes I try to see a correlation in when the tank was doing really well, because I know based on looking at photos of the systems, when it was really in one of those strides, like I talked about. And it's not, I can't come to any really solid conclusions based on the inorganic chemistry a lot of the time. It's like, okay, well, those things were low and then, the tank was doing great. It's like, doesn't really explain that much. So, the other factor I think about is bacteria and these populations of bacteria and how they affect our tanks. But then there's this whole other part to the equation that I never considered, which is these dissolved organic carbons and, their relationship with bacteria. So I don't know, maybe you can talk about that a little bit and kind of, where this is going.
Yeah, so I think where this is going, or at least what I'm trying to put out there conversation-wise, is that we need to stop looking at one piece at a time. This is really a very complex multimodal system in which all of these things interact. The inorganic chemistry, the organic chemistry, and the microbiology are all very much intertwined in a complex biochemical system. And for the first time, because we now have, in-doc testing, we have microbiology testing, at least in the United States. These are things we can begin to look at. And then that's basically what academia is doing with multi-omics design in terms of their experiments, where they're looking at all these different variables simultaneously and putting them together. So if we're looking at all of these things, I mean, it's like what Christoph talked about, right? The bioavailability of different trace elements in the inorganic chemistry will inform metabolism and the molecular world. Dissolved organic carbons can influence the rate at which those things are uptaken and processed. I mean, it all is very interconnected. In terms of the direct relationship that's at least observable in the literature right now between the microbiome and DOC, like I said, there's a very, very clear established relationship. So as DOC continues to climb, there is a positive linear correlation with how should I phrase this? Basically, like temporal pathogenic gene expression. So essentially, you have a lot of bacteria that are good guys, or they're at least benign. And whenever the environment is good, there's low carbon. It's an oligotrophic environment. There's a lot of the good guys that dominate that population. As that carbon gradient shifts to becoming higher and higher in carbon concentration, it becomes copiotrophic. At that point, many of these bacteria that are like sleeper cells will activate multiple gene pathways in which they become pathogenic. They'll begin growing exponentially. They'll form biofilms. They'll release toxins. They can respond to chemotactic signals and basically swim towards stressed out corals with different types of invochemicals like DMSP. So it really lets the cat out of the bag and begins adding fuel to the fire. So keeping that DOC low is probably one of the major determinants to the microbiome, as well as having all of the traces that are necessary for contemporary metabolism in order. So it's all
Yeah.
very interlinked. It's very complex.
Well, I'm wondering about the correlation of pH, because you kind of made the point in the article that you would rather see a tank with lower pH and low DOC levels than a tank with higher pH and high DOC levels. Because I've always kind of thought that some of these sort of bad guy bacteria are more likely to sort of proliferate at these lower pH zones. But I could be wrong. That could be a bit too vague of a statement, maybe.
Pretty much, yeah. I mean, that's
Yeah.
the thing is like a lot of people in the industry and writ large like to have very totalistic statements about the microbiome or any of this stuff. And that's a very human limiting conception, right? We like to view things in yes or no, black and white in terms of duality. And all of this is pretty much beyond human comprehension, and we're attempting to put it into a box. Only now, through having all this multi-omics data, are we finally getting an accurate view of it. And many of the cutting-edge papers are having to use algorithms, AI models, stochastic mathematical models that are non-linear to even predict these systems. So because we like to view things in a top-down and linear way, I mean, this is kind of against how we typically view things. So just like low pH equals bad guy, like that's some of this is unrelated, but some of my qualms with Alan, right? He's like, yeah, the concoction is not going to have any bad guys. It's got a high pH. It's like, yeah, all right, sure, that's wishful thinking, but there's a lot more at play there. So pH is great, right? Chasing pH, stable high pH is fantastic. It really is a central regulator in terms of everything, right? The higher the pH, the more natural the pH, 8.4 plus, you got calcification. It's occurring a lot better there. The coral's immune response is a lot better. But DOC is just so strongly linked statistically to pathogenic gene expression, to infection of corals. In my mind, I've had plenty of systems to where I've, in the beginning, like 7.8 pH to 8.0, and they weren't perfect. I didn't have the best growth or color, but things were alive. And I did a lot of water changes. But in my mind, in systems where I don't do that nutrient export, where I don't have removal of organics, I always see problems. So that was kind of my mind, is pH is very important, but this is likely a much bigger and more important dragon to chase above even pH. And I think it's easy to have a system where you have both of these balanced. I mean, I think that having kalkwasser or the introduction of hydroxides is a potential reduction method of DOC. So they're very synergistic in how these can be managed.
Okay. Yeah, that's interesting because that wasn't mentioned in the article, but that'll be something that'll come probably a little later in terms of all this stuff you're gathering to kind of put this case together. Yeah. A point you kind of made is like, I think the saltwater hobby is obviously it's based on a lot of anecdotal hobbyist contribution, and that's great. And I kind of wondered, like, part of this article was inspired from your trip to the Bahamas, right, where you saw these reefs kind of suffering. How much of that, DOC related issues that we're seeing in the ocean, how much of the science applied to that really applies to our at-home aquariums? Because it's obviously such a different environment, right?
I think it's a different environment, but in a way that actually favors us. We can't do a water change on the ocean. We can't run ozone or have a skimmer. But I think that the principles in terms of the microbiology, that's very conserved, right? Coral biology is something that is conserved even in our systems. If we add the right elements, we have coral growth. And the microbial world, at least in the controlled experiments I've done, and that have been done by many labs across the world, it behaves in the same conserved pattern. But I think we have the advantage in that we can control that environment much more. So what we're seeing in the ocean right now, I think is what we could see in a lot of systems that don't do water changes, right? That do the shine or do the Triton method. I think after a long time, that's what you would see in those tanks with the buildup of DOC if you don't have any export. So I saw it as simply, I had thought about these things for a long time, but it really was a catalyst for me writing it. I had not spoken about them, and I was like, oh my God, this is terrible. I'm like, oh, well, this is happening in a lot of people's tanks. I'll talk about this part right now. We can start talking about it. So yeah, it was a lot of introspection and putting things together to write that. But yeah, like I say, I think it's similar enough to where these would be conserved patterns. I mean, these animals, these systems have evolved for millions of years to where if you have that type of shift in chemical parameters, even if it's in a glass box, it's going to behave the same way.
Yeah, totally. Yeah, it's I mean, your article is very good timing because it seems like some of these companies are investing more in, putting a DOC test along with their ICP or laboratory tests that they do. So, can you speak to the some of the tests that are on the market? Because obviously, Oceamo just added their the SAC 252, which I talked about with Chris. There's the Triton M-Doc. I think Fauna Marine maybe is coming out with one, or at least as an add-on to their total ICP. But what are sort of the strengths and weaknesses of these tests, and what kind of picture are we getting from them?
Yeah, so I think having the photometric based method that Christoph offers is something that's a really good step in the right direction, right? To have that as a baked-in cost to an MS test, that's great that someone's offering that. But there are limitations to it. So if you're having a 250 nanometer, 54 nanometer absorption rate, that's really only going to look at conjugated systems and like aromatic systems. So the most important thing to know about DOC, or to really get about it, is that it's kind of like alkalinity. It is a chemical parameter which encompasses many different chemical groups. Alkalinity is a measure of the total buffering capacity of a system towards pH. DOC has every single dissolved organic carbon compound. You've got carbohydrates, amino acids, proteins, lipids, phenol compounds, organic acids like formic acid or acetic acid,
Yeah,
polyphenols, pigments, urea, polysaccharides, humic substances. I can keep going on.
yeah,
And
yeah.
254 nanometers, that's really only a small subset of that. You'll get some of the humic acids, you'll get phenol compounds, aromatic hydrocarbons. So I think that it's great. And you're going to get those things that basically contribute to the yellowing of the water, like a tannin, if you're thinking freshwater, tea or whatever. So I think that if you're doing general troubleshooting, you're not having issues, you've got your ICP, like your inorganics in line, and you have a low value there, you likely have a low value elsewhere, but that doesn't mean that your DOC is low. I think even if you've kind of checked all of those numbers, chased that dragon there from like the Oceamo test, and you're still having issues, that's when sending in something like an NDOC would be beneficial, because you might have selective increases of the other DOC components that you're not going to be verifying through that testing method.
Okay, so what is the difference in the M-Doc then compared to this SAC?
Yeah,
Is it
so
seeing a broader spectrum?
yeah, it's getting everything. So
Yeah.
they use a total carbon analyzer. So it's all organic carbon in the system. Every single compound that can contribute to that. You also get the organic nitrogen, which is pretty cool too. And that's a whole other rabbit hole. So I mean, yeah, the spectrophotometer, it's like a Hanna checker. You just have a vial, you measure the absorbance of everything in that wavelength of UV light, and then it'll give you a value based on a control sample. But in this instance, there's only a small number of chemicals that are able to be absorbed by that wavelength of light. Whereas the total carbon analyzer is a completely different piece of analytical equipment, which will give you the full picture, the total carbon.
Mm-hmm. But the SAC may still be a good enough indication if some of these things are in relation to what it sees. Because also Christoph mentioned that it's not necessarily the yellowing of the water compounds that are picked up in that nanometer. Some of those are actually not ones that you would see in that range.
Yeah, sure. Like, so that's part of it. It's like the humic and fluvic substances are kind of like the tannins, which you would see with the yellowing. But there's also things that are not visible to the naked eye. So any type of basically ring structure or double bonds, so conjugated systems, that's all that's getting picked up by 254 nanometer absorption. But again, that's not the whole picture. Now, what we don't know is, do the concentration of aromatic or conjugated organic systems correlate to the other organic systems?
Yeah.
We got to test that. So maybe.
Yeah, interesting. Well, yeah, it'll be interesting to see if more companies are adding this as an add-on, because, the M-Doc, it's like if you're just sending that off, you're paying for shipping, you're paying for the test. I think it's a nice thing to add to an ICP you're already sending off. And even if it's just like an add-on fee, like you're already sending the water sample in. So I hope it becomes more of like a standardized thing. I'm hopeful for that for sure.
There definitely seems to be a lot of dialogue around, after the article came out, that people are interested in this. A lot of big names are. So I think that Christoph doing that, probably there'll be a lot of followers there doing the same method, because it's relatively inexpensive. It's like, maybe $2,000, 2,500 for a decent spectrophotometer. This is a very easy method to do. You just pop it in, you measure the absorption, good to go. So
Yeah.
Yeah,
Yeah,
it'd
yeah.
be easy for most companies to add on for sure.
Yeah, and he also mentioned that the stability of the samples held pretty well. So he was confident that during shipping you wouldn't have much of a change in the sample. So,
Yes,
that's
that's
promising
good to
too.
hear. Yeah,
Yeah,
that's something
yeah,
I would not know about because, yeah, not
yeah. You don't
tested
have
it.
the
So,
equipment. Yeah,
yeah.
totally. Yeah. An interesting thing I also read in the article was amino acids are going to contribute to these dissolved carbons, and it's like a lot of people use aminos in their systems. Also, not to mention, like a lot of amino acids are probably getting into your system through your feeding. However, at what point do those, fish foods, coral foods become a dissolved organic carbon source as opposed to just being undissolved? Because, I'm kind of like trying to understand that difference of when things dissolve.
So everything dissolves, right? Any type of nutrient input, anything you add to your system is going to contribute to that dissolved organic carbon pool. In my mind, it's a sliding scale. It's a question of minimizing that import. So if you're adding purified amino acids in a bottle, that is much more quickly going to contribute to that. It's a much more simple compound. It's not in a pellet. It's not processed. Doesn't have to go through a fish, et cetera. It just enters the system, begins to immediately disassociate and break down that system and add to that pool. So, I mean, I think that the name of the game is eliminating as many of those unknown or uncontrollable dissolved organic carbon inputs as possible. So then we can control it through selective feeding, and then we can manage our export a lot better. But in my mind, like you said, fish food, it's all going to break down. It's going to provide histidine, right, which corals can't synthesize. In my mind, adding purified amino acids is something that was a fad that really took advantage of a lot of people's ignorance, or the companies were ignorant themselves. I mean, it's not just that aminos add to the dissolved organic carbon pool. There's a lot of research that shows that amino acids are very, very bad in terms of coral pathogens. So in terms of an infochemical, if corals go through a stress event, naturally they will break, like the zooxanthellae gets stressed, and because of that, there's less efficient photosynthesis. The coral then has basically carbon sources inside of it. It breaks down. The residual, like the result of that is then amino acids will build up in concentration in the mucus. Vibrio and other coral pathogens have evolved to respond to those amino acids. So if there's a heightened increase of amino acids in the water, they will then swim towards that coral and they can sense it's a stressed coral.
Oh,
So in my
really?
mind,
Hmm.
if we're adding any of these brands, it's like a lightning rod. And I've seen so many anecdotal results of people saying, I added this and then I got brown jelly.
Mhm.
Well,
Yeah, it
makes a
makes
lot of
sense.
sense.
Yeah, I mean, and I think there is an application for amino acids. I think sometimes like a very young, newer system that's, kind of the biology has not really kicked into gear yet. Maybe aminos might be something that could get a little bit more utilization. But yeah, I mean, I haven't been dosing any of them, and I almost think that there's probably enough aminos going into my system from my feeding as it is, to even
Yeah, I mean,
consider putting a product in.
yeah, if you're feeding your fish, if you have fish, if you're using coral food, those are all sources of amino acids. And I think there is application. I don't want to just say all aminos are evil.
Yeah, yeah.
Like Sarah Stevens of the Butterfly Pavilion, she works for the Florida Reef Track Restoration Program here in Denver. And she went down and was taking care of staghorns, like the endangered, Acroporus cervicornis. And they had a bunch of them completely bleached. And they did controlled baths with amino acids. They were able to bring them back. So in
Interesting.
instances like that, where maybe you have stress from shipping with things that are already bleached, it could be a very good shot in the arm. But adding them to a system already, maybe not.
Well, aminos are like building blocks for proteins, right? Is that kind of a simple way to put it? Yeah, so
Pretty
maybe
much,
if it's a coral that's rebuilding tissue, not just necessarily, density of zooxanthellae, it may be a better influencing factor on the coral's health. I don't know. I mean, hard to
Like I
say.
say, I think it's definitely a useful tool, but it's one that is being used a bit too hastily right now.
Yeah, it's a lot of marketing. I mean, not calling any companies out, but it's for sure, totally. You mentioned carbon sources or say carbon dosing. It's been a popular thing for, I'd say, probably over 10 years, 15 years since people have been putting vodka, vinegar, sources like that. There's obviously different types of carbon dosing you can do, but this is contributing to problems with DOC overall. I mean, we're not saying don't do it if it's working for your tank, maybe continue doing what works, but what are the risks with this?
I think everything we talked about, right? I mean,
Yeah.
DOC, dissolved organic carbon, you are adding dissolved organic carbon to your tank. That is what carbon sourcing does. So, I mean, we're doing a community experiment with aquabiomics, which will get started in about a week now. So we're going to have 3 different carbon sources, an amino acid source that's commercially available, and then we will have vinegar and vodka, and we will track both the microbiome, and we'll have NDOC data over a period of a month. So we will be able to answer, does this increase pathogenic families? We know from things like Sanjay and Kid Feldman's work in 2010, where they use flow cytometry, it indeed increases planktonic families of bacteria in the water column. We see that removal through nitrates and phosphates. I mean, it's the same thing as a refugium, though. You're removing nitrates and phosphates, the inorganic pollutants, but you're increasing your organic carbon as a pollutant in doing that. So it's a double-edged sword, whereas something like a water change or selective chemical media removes all of that uniformly. So, I mean, like I say, dissolved organic carbon, though, all the same threats if you're carbon dosing as that. So you could be directly feeding the pathogenic bacteria.
Yeah.
The most important, oh, sorry, go ahead.
I was just going to say, because I know there's like different forms of carbon sources you can dose, which are some are more of a complex chain and some are more of a simple. So like with the complex chains have, potentially be more available for some of the better strains of bacteria to utilize, like, or would it still just contribute to that overall DOC level?
That's
really
all, based on what I know, that's all marketing. That is marketing hype from ignorant people. And there's a lot of them. So
Yeah.
here's basically how this works, right? The good bacteria, things like Endozoicomonas, Pelagibacter acea, the SAR 11 clade, Syncococcus, some of the cyanobacteria that are single-celled that are beneficial, they have evolved to only eat about 3 or 4 primary carbon sources, which the coral directly produces when it's in a healthy state. Those are not in the bottom. Those are things that we do not have commercially available, even from Sigma Aldrich, Fisher Scientific. They are things which we would have to synthesize in a lab because they're so exact and weird that corals produce naturally. When the coral goes through that stress event, like I explained, there's a buildup of amino acids and complex sugars from breaking down internal carbon reserves, and that changes the carbon composition in the mucus, and that feeds the bad bacteria. The bad bacteria are basically able to eat any carbon source. They are very adept at eating everything. The good guys can only eat a few. So because there are none of these few on the market, at least that I know of, and that any company has advertised, any carbon source we're adding is allowing for those bad guys, which are more adept at growing and utilizing those than any of the good guys, to proliferate. So in my mind, we're likely just really messing up the microbiome with any carbon source.
Okay, that's interesting. I've experimented with a few different carbon sources from different, product lines, and it's changed my nutrients a little bit, but I have not been aware of, what are the repercussions or effect on other factors. So it's definitely something I'm considering now. This is all like this whole other open area we can look at now for solving problems, really, because that's half of the probably more than half of the hobby. It's probably 3/4 of the hobby is just solving issues or at least avoiding issues. So yeah. So one thing you mentioned was one of the probably best solutions is cryptic sump with sponges. And I've always run a cryptic sump, and I've always had a lot of sponges in my sump. And I ended up doing this test with Oceamo with his SAC test, and I did get a fairly high level. I got a 12, and his range is 2 to 8. So I'm just thinking about what other things I can do. I've never been a huge, really super consistent water changer, so maybe that's probably something I should do more often. But at the same time, I have good results. I do believe in getting your water chemistry kind of dialed into where you want it and not messing with it too much once it's there too. So I don't know. What do you think my solution is for, improving that number?
So the first thing I'll say is that I think that cryptic sumps, while on paper, can definitely work, and I've seen benefits from having them. What we don't know and what needs to be tested is how large of a cryptic sump would we need to match like how much sponge per nutrient input, right? That's a pretty hard thing to quantify. And I don't think that it's like the sole savior to our issues. I think we're going to need a pretty multimodal approach, but it can passively manage some excess DOC. I think that water changes are definitely the cheapest and the best option. There's a lot of data from wastewater that, carbon, granular activated carbon, can take out a lot of these compounds as well. So running carbon can be good so long as you're keeping your traces in order as well, because that can complicate things. I think that also, you see, ozone is one to toy with, I think. I think that at least as of now, the data set we have is that ozone definitely nukes the microbiome and kills a lot of the good bacteria. But
Yeah, you were
potentially,
saying that. Yeah. So some of the is it the Plagiabacter? That's kind of one of our kind of good aquarium strains that we want. Yeah. Yeah, we don't want to mess with that one.
probably not. But I mean,
Yeah.
there might be a selective way to run ozone only for like a little bit to where we don't. That needs to be tested and experimented with. But as of now, ozone on balance seems like not the best approach. But I've just been using like I've ran like what is it? God, what's that super generic like the chemical media they sell at like Petco? Oh my God. The blue one. I can't remember the name of it.
Yeah,
Jeez, it's
I'm
I don't
spacing out
remember.
too.
It's like Kimmy Pure Blue, right?
Yeah,
I,
yeah.
I threw Kimmy Pure Blue and my sub, and I've been running carbon, and I've been doing a ton of water changes, and my ORP has been going up pretty steadily. But
Mhm.
I also never did water changes on my system for like a year plus. I just read about traces, and things were relatively fine until they weren't. And that
Mhm.
was the only. It's like, okay, this is an issue. So I've really got in there and removed all the detritus I can manually. I think that was something you and me and Andrew Bauma and
Mhm.
Bob Stark had a conversation about on Facebook. And the more I've thought about it, I think it really makes sense that a lot of the DOC could be sequestered within detritus. And we at least know that a lot of the pathogenic bacteria definitely live associated with detritus. Removing that
Yeah,
is probably a good thing. And
yeah.
just doing the really dirty work of like every
Mhm.
inch of the sum.
Yeah, because some of that detritus is probably coming in and out of dissolve solution, right? Like it's sitting there, but it's probably there's various factors. Maybe it dissolves more in these lower pH ranges. I don't know, but yeah, and that's why I think maybe like a filter roller is clearly a better way to, even though these are particulates. You're pulling them out of the tank and raising them out of the water before they have the chance to dissolve back in. Versus a filter sock, it's like I don't know how often you change it, but it's going to pull those things out, but they're still sitting there dissolving. So, yeah. So, yeah, it'd be interesting to see if you get a
Yeah,
little
I
bit more
think a
data
roller
on the
met's a great
detritus.
tool.
Yeah, yeah, for sure. Yeah.
Yeah, that would be a cool thing to test. I think Bob is super interested in exploring that rabbit hole further. He's a big chemistry guy, so he's
Yeah.
excited by all this for sure.
He's great. I love when he gives a good long response in a thread. It's just like all awesomeness.
Yeah.
Yeah, he's great. Yeah, totally. Yeah, well, I mean, that was most of my questions about this stuff. Was there anything else you kind of wanted to mention as far as where this is going on your side? I mean, we're going to kind of see some data from these systems you're testing on. Oh, I meant to also ask, are these three isolated systems with coral fish like they are like a reef, like a small reef setup? Yeah,
Yeah, these are actual hobbyists. So I sent out
yeah,
like basically it's a community science experiment. So people with active running tanks. We just, try to get as controlled as possible. People that already were not adding carbon sources, biopellets, things like that. And we got some really good candidates that have really low nutrient input. And we also wanted people who are not doing water changes or do them, not so often. So we're going to ask they don't do water changes, add any chemical media during the duration of the experiment. They weigh out their food daily, things like that. So this should give us a really good idea of what this is going to look like. It's about as controlled as we can get with a system, I think.
yeah. How many pictures of that system are you taking over this duration? Will it be once a month or something like that? Like
Sorry,
obviously
they're messing around.
that's all right. So you probably do one at the start of all of these systems and then intermittently throughout the period that you're letting this test go on for.
Yeah, so these are all existing systems that have been set up for years or
Yeah.
varying lengths of time. There's going to be 3 time points. So the first one will be a baseline. Then we'll have a 2-week period where they do nothing. It'll be an internal control. So we'll see how much their DOC, their microbiome shift. And then we'll have a
Yeah.
2-week treatment period. And then we'll do a final thing there. So then we can
Cool.
compare statistically the increase or decrease in DOC in the individual bacterial taxa. And then we can do that across samples as well. So we can actually It wouldn't be statistically significant at this time because we don't have a large enough sample size, but this is something of a pilot study. If we see very clear data, then we can then get more people involved. We didn't want to spend the money to have 28 participants and then have nothing. So
yeah. And I mean, I guess you just have to be clear with these testers, like, don't do anything else. That we need to know everything that you're doing. Don't put any other products in, just do your husbandry as you would and make these specific changes. So that's the only way to really learn anything in this hobby, right?
Pretty much.
Do one thing at a time. Yeah.
Yeah. And like in the fall, it's almost already the fall, probably the winter now, we're going to be doing DOC exports. So we'll try different export methods and see how that potentially affects the microbiome as well. And then we'll just keep continuing with Triton and Aquabiomics. They're both very happy to be a part of this and provide things. So I think it'll be pretty cool. And then I've got all the data for my stuff. So hopefully we'll have a lot of things coming together in the next, like 2025, to really begin chasing some new dragons, I think, and really getting the next level of things.
Yeah, cool, man. Well, I really appreciate the work you're doing and, the work you put into this article and taking the time to talk to me. So keep doing what you're doing, man. It's awesome. Can't wait to see what you do over the next few years. It's awesome stuff.
Thanks, man. Yeah, thanks for having me. I wanted to get on. We talked about it earlier, so
yeah,
I'm glad we got at least something done.
Yeah, totally. Yeah, it's awesome.
I'm sure we'll do much more in the future. So
totally. Yeah, cool, man.
Thanks for having me, man.
Yeah, cheers. Thanks for listening to this episode with Christoph Denk from Oceamo and Salem Clemens from Reef Builders. I hope it got you thinking about some stuff, and maybe you're going to do a few more water changes, maybe put a little more activated carbon in, and make sure you check out the articles in the links below in the description. Just another shout out to our sponsor, Fauna Marine. Definitely check out some of their new exciting products that they brought to the market this year. If you have any suggestions for future guests, want to ask me a question, or just reach out in general, you can email me at beyondthereefpod@gmail.com. And if you're looking for high-quality aquacultured corals in Canada, please go to my website at fraggarage.ca. Hope to hear from you soon.